Here's a quick review on like terms and order of operations with substitution. So what are like terms? Like terms are terms that contain the same variables raised to the same power. And remember, variables is a mathematic term for the letters that are represented in a math expression. So if we look at this first example, we want to collect like terms in each of these expressions. Well, the first thing I'm going to do is I'm going to regroup these expressions to put like terms together, and then we're going to collect them. So this first term has x raised to the power of 2. Well, we have x in the second term, but it's not to the power of 2. And then here we have x to the power of 2. So these terms are like terms. I'm just going to right now rewrite them in that order. Then we have 3x. We also have x here. These are both raised to the power of 1, so I'm going to rewrite them in that order. And then lastly, here we have a number, a constant, so it doesn't have a variable with it. And we also have a constant here. So what I've done is I've just rewritten the terms so that the like terms are beside each other. Now let's collect like terms. So 8x squared minus 6x squared is 2x squared. If we collect 3 and negative 8, we get negative 5x. And collecting 7 and 4, we get 11. So this would be our final answer. So in the next example, I'm not going to do that middle step. I'm not going to reorder it. I'm just going to collect like terms. Here we have a and b, both raised to the power of 1. We only have a in the second term, only b. Here we have a and b again. So these are like terms. 5 minus 1 is 4ab. Here we have a. Well, we do not have just a in any other term, so therefore that is the only term that's just a. Here we have b. We also have b here. 2 plus 3 is 5b. And in the last term, we have a raised to the power of 2. Of course, it's the only term left, so there are no other like terms. So in this example, we only had 2 pair of like terms. The other 2 terms were the alone. Next, we're going to talk about order of operations with substitution. So in this example, we're going to let a, the variable a, represent the number 2, b, negative 3, and c, 5. And we want to evaluate these expressions. The first thing we're going to do is substitute in these 3 numbers. So if we substitute in 2 for a, we get 2 squared, minus 3. If we substitute in negative 3 for b, we get negative 3 there, plus c, which is 5. Now, if you notice, I put parentheses around the numbers that I substituted in. This just helps us to realize where the numbers are and also what operations we have here. So in this example, the first term, we have 2 raised to the power of 2. The only operation is the exponent, so let's do that. 2 to the power of 2. Next, we have subtraction. Well, if we know our order of operations, subtraction comes towards the end. So we multiply 3 and negative 3 to get negative 9. If we subtract a negative 9, that's the same thing as adding 9. And then lastly, I'm just going to recopy the last term. So using order of operations, we did the exponent first here in the first term. We did multiplication first in the second term. And now we're going to collect like terms. 4 plus 9 plus 5 is 18. In our second example here, we're going to do, just like the first example, we're going to substitute in our a value, 2. So we have 2 times 2. We're substituting in our b value, negative 3 squared, and substituting in our c value. Now, in the numerator, the first term here, 2 times 2, multiplication, we get 4. But the second term, what's important to realize here is that with order of operations, exponents come before multiplication, division, subtraction, addition, all of that. So if we wanted to simplify this, we would first have to raise negative 3 to the power of 2. And if we raise a negative to an even power, we get a positive. Negative 3 times negative 3 is positive 9. So 4 minus a positive 9 on the numerator. And we're just going to rewrite the denominator, the bottom. So now if we simplify the top, 4 minus 9 is negative 5. Negative 5 divided by positive 5 is negative 1. our final answer.